good afternoon, good morning, wherever you are in the time zones. It's such a pleasure to see you all live for this Atos Manufacturing Fireside Chat. Today, again, about the topic of decarbonization. We got a lot of feedback on decarbonization. We already had a talk with BASF a couple of weeks ago, and we're going to share the link to sort of the first episode on decarbonization and the proto-carbon footprint. Today, we're going to have a second session on decarbonization, specialized for the chemical and process industries, about the automated proto-carbon footprint. It's really so great to see you all here. We had so many people already writing us in advance, and I'm so happy. If you are joining this session today, please post your comments in the video and we'll try to take care of those. But today, it's not just me talking again. I have so many great guests. So let's say two of them that will shed some light on what we're going to talk about. And first of all, let me introduce Stefan Unterhuber. Some of you might already know him. He's a Senior Director of Decarbonization at Atos. Stefan, great you are with us today.
Happy to be on the show again.
That's perfect. That's perfect. You are already like, a concurrent guest. So I would say we're going to start off with a decarbonization session itself. So a subtopic of that. It's the second session of the Fireside Chats in this year. So great. But today we are not alone, Stefan. We have another guest. And we bring up Arne Katelhon, Managing Director of Carbon Mines. And it's so great to have you here. And today you both are going to have a great conversation about decarbonization. You're going to shed some light about the chemical and process industry, why it is so important. And in the pre-talk, we were already talking about like automated carbon footprint analytics of microplastics. We are far away from that. So let's take the step back to where the production starts. And I think we agree there are some leading questions. First of all, why carbon footprint? Why is it that important? Why do we need it? Why is it really, just like especially when we start in the production process, so important to have something like that? And maybe I will just hand over to you, dear participants, and go for the answering of the question.
Okay, yeah, great. I can take on that. We spoke about that in the last session with Alessandro Castillo from BASF already.
Right.
So not to repeat too much about that, but the product carbon footprint, especially for the chemical and process industry, we believe is key to them understand where their emissions come from. It's key for them to build a base on their actions for reduction targets that they have set. If you want to reduce emissions for your whole company and you're a production company, then start with your products. So it's essential to understand that. And maybe Arne, you want to add something to that?
Yeah, absolutely. Maybe to start with, intuitively, when you think of the emissions of the company, you often think of the direct emissions, but this is just the tip of the iceberg. So a much bigger part of the emissions, it comes from the supply chain. It depends on what resources are used in the supply chain of your products. What are the production steps in between? And the sum of all these emissions, they account for the environmental impacts of a company. So we really need to understand this in order to tackle climate problems and find the best way to do it to reduce climate impacts.
And I think especially in the process and chemical industry, those emissions that you mentioned, Arne, we said it's above 70% of all of your emissions, can be up to 80, 90% even, but 70 is a good average, what we believe. So it's really, it's the most important factor, the biggest impact category that we can possibly look at.
Well, sure, that makes sense. If we can tackle those 70, 80%, well, that's the biggest leverage which could be applied. But that's also something like, how can we, it's like we always talking about automatic proto-carbon footprint, about the calculation. It's like, how do you calculate it to get the value to say like, okay, 70% sounds nice and a huge number, but it's like, how do the numbers come in there? Where is all that data coming from? Where is it going to? Where do we need to get it going?
Yeah. That's a difficult part.
I never said I'm going to make it easy.
Supply chains are long. They consist of many different production steps carried out by different companies in different countries in the world. And all these countries, they have different production mixes, different emissions profiles. So you can't really call all of those people along the supply chain and just ask them for their carbon footprint. You really need to model all the supply chains really from the resources to the final product that a company really buys. And you don't need to do this for one product or for the average product. No, chemical companies, they typically have between 500 and 20,000 different impacts. And you need this data basically for every single of their inputs.
Wow, that sounds like a lot of work. Yeah, Stefan, please.
Yeah, I just wanted to add, as you mentioned, the regions. So it's a big difference if you source your raw materials from Europe or from Asia or from the US. So that makes a big difference. It's also a big difference how it has been produced. It has been produced using process A or using process B. And what we see when we help customers calculate their product carbon footprints is that a lot of data that they have under control is available, or they can at least make the effort to make it available. Right. But this kind of data we're talking about today is the one that's a bit out of your control, because that's the data that comes from your suppliers. So you can either ask them, as Arne said, you can call them, ask them, or and many companies do that, and that is something that we will see more and more. But as Arne rightfully said, that's a way that is long, it's cumbersome, and it doesn't lead to immediate results. So what you do for all the thousands of raw materials, and there Carbon Minds has come up with the solution to build a database. Arne, maybe you want, or you can explain in this session how you did that.
Yeah.
Well, that would be great, because I just like thinking about like calling every supplier for just like, oh, hello, my name is Friso. I would like to know more about the products or the raw materials I'm buying. Could you give me a rough number? And then I start like a huge spreadsheet and calculate everything together. You've done it the other way, Arne, right?
Yeah. Only in our database, we have more than 18,000 specific plants and more than 100,000 processes. So imagine you would call all these people. We did it differently. So we basically built a digital model of the global chemical industry. You can imagine us really starting from the oil, from other feedstocks, and then build up all the supply chains, first for the large volume chemicals on plant-specific data, like how are plants clustered and integrated production sites, how are they integrated with each other, what are the chemicals they produce, what are the emissions along the supply chains, where do the international trade flows go. So basically, as precise as possible, digital representation of global supply chain. The entire model is built in a way that it's compliant with the major environmental standards. First and foremost, the standard for life cycle assessment, the ISO standard for this, so that we can use this model to extract environmental data, all the emissions that are emitted along these supply chains. We can characterize them regarding their impact on climate change and many other environmental impact category. And yeah, the coverage is large. We have more than 1,000 chemicals. The regionalization is big. We do this for all production regions in the world, really highly regionalized impacts throughout the entire supply chain. And this is exactly the data that you would need to represent the purchases that you have as a company in order to even be able to start doing your life cycle assessment or your carbon footprinting. And this is all where our work comes together with Stefan and Atos.
That was so interesting when we first learned about Carbon Minds. It was almost a year back that we had our very first conversation, and you explained that you could tell supplier-specific product carbon footprint data without actually calling those guys. So that was the moment when we said, how do you do that? How can you actually tell how much is the carbon backpack of that product coming out of that plant in that region? And then they explain how they do it and with their knowledge. And then we said, ultimately, this is something that we need to build into our product. This is something that we need to have access to. And that's one of the reasons behind the call today, that we can announce that we are in fact partnering, teaming up together so that we can make use of the great data that Carbon Minds has created and build that into our solutions.
Wow, that sounds perfect and great, and congratulations. I think that's a perfect match because, well, just like while you were talking, Arne, I was like really visualizing how you could do that. You said like starting by a single plant or whatever. So I was like, is there an example of how can I imagine where is the difference? For that also means like buying the same product or the same raw material, having a different production site, just like makes a lot of difference, maybe because of the supply chain in regards of what comes out in the carbon footprint calculation, or right?
Yeah, absolutely. Okay. I mean, every chemical, they have the same name. They are structurally different. If you put them under a microscope, it will be the same chemical, but you can produce exactly this chemical in so many different ways. One typical example is coal-based production in China. And many people know the debate on coal for electricity production. It's pretty much the same for chemicals. If you use coal as a chemical feedstock to really incorporate it in the chemicals, it relates to much higher emissions for exactly the same product. So sometimes there's even a factor 10 in between suppliers and equally large differences among the regions. So what has been done in the past a lot is that you would use global average data, global average carbon footprint for a specific chemical. There is nothing like a global average that is representative of your own supply chain. So individual regions, they can be, I don't know, 200, 400, 500% different compared to these global averages. So if you want to understand our impact, if we want to be able to do something about it, we need this granularity, because this will allow you to make the decision where to source your products, what suppliers to choose in the end, and how to make the entire system better. So it gives you granularity, but it also gives you the levers for improvements. Yeah.
Mm-hmm. So it's going from an educated guess, so to say, like the average carbon footprint, to like a way more accurate level. Is there something you could say about the accuracy? You don't want to just like go on details, but just like how far is the gap between guessing and knowing?
Let me give you an example. Polypropylene production. It ranged in our database. If you again take China as an example, like the average carbon footprint would be around 4, a little bit lower, but individual suppliers range from 1 to 11. And
kilogram per kilogram, just for everybody watching.
Yeah,
4 grams
yeah.
per kilogram.
Yeah, exactly. We always calculate this in kilogram kilogram CO2 equivalent per kilogram of product. So meaning there's easily a factor 10 between suppliers, and maybe for this example, factor 4 or 5 between regions.
Well, that's amazing. And Stefan, this is not just like going that you understand your carbon footprint, but also like you mentioned it somehow, Arne. It's also about like planning, changing a supply chain, maybe changing a production site. Just like there are so many things you could do besides knowing about the carbon footprint, but also like how you deal with that and how you can make it better.
Yeah, exactly. You need exact data, as Arne just explained. If you do your optimizations based on a global average, you might be optimizing something that's not there, because you're actually not using that global average. You have a much lower footprint, or the other way around, you're not optimizing something that needs optimization because you believe in a too low footprint. So either way, you're investing your money at the wrong place. So having exact data is crucial to do the calculation, have confidence in the result, act on the result. And that's one thing. And the other thing that that's one of the other reasons why we said we need Carbon Minds to join us in our go-to-market, in our solutioning. We can also use their extensive database to benchmark results. So let's say you have calculated your product carbon footprint, and you're not sure if you have done it right, then you could compare it with the database where the same material is already in. So you know the region, you know the material code, you know the production process, and then you can compare, and you already know, am I in the range that's reasonable, or am I off, so I might have done something wrong. So also this pretty straightforward use case is one of the reasons why we said that's absolutely of value to the chemical companies.
Right, that makes sense. So is that also an approach for me as a possible customer, or just in the chemical and process industry, to say like, hey, I have those values here right now. Could you like recheck to get an understanding how near I am? So, or let's say, great that you created that solution. I'm in it. How can I get it up and running for me? How can I get in contact? How can I get like some basic values also to do my calculation? Because at the end of the day, it's always also an investment, and I need to make sure that it pays off at some times, right?
Yeah, this is definitely a use case. So in reality, it will always be a mix between data that you have collected from supplier,
Right.
and between so-called secondary data from databases like ours that you use for all other parts. But it's true for the supplier data. I mean, in this collaboration, we have country-specific data for more than 190 countries, thousands of chemicals, and for all the large volume chemicals, really every industrial relevant technology. So it's not only comparing it to an average. No, you can look up what is the technology that the supplier has in the assessment and compare it. So this benchmarking case is definitely important. Still, the far bigger case would be to use the data, right, for the calculations. And here, if it's integrated into the Atos PCA and PCF tool, this is super powerful, because you have your supply chains right in the tool. You can connect it with your own primary data, your energy demands, your direct emissions, and get out really the LCA for entire portfolios. And this makes the approach much, much faster, and also the data quality more consistent in the end.
Wow, okay. You mentioned now that the Proto Carbon Footprint, the PCF platform, and also to share that, and also for the audience who is a little bit shy today in regards of comments. So feel free to get your comments in going. I will just like put that link in here in the video, but I'm also going to simultaneously put it here on the LinkedIn chat in that video, so you can all access it. Let's make it happen. I just have to switch over. Something you want to mention about that platform, Stefan,
Yeah.
for example?
Yeah, sure. We've spoken about that with Alessandro from BSF last time, but
right,
mentioning that the in a nutshell, the approach is have a automated full portfolio calculation for chemical and process industry. So all of your hundreds, all of your thousands of products at a mouse click. And if you want to increase accuracy and availability of data, then there comes the secondary databases in, and that's exactly where what we spoke about last time, the actual platform to calculate and the data that Carbon Minds provides meet. Yeah? And the two use cases are improve the data for calculation and also use the data for benchmarking and do a sanity check on your intermediate results. So this is why it was so important for us to team up and create additional value by doing so.
Great. So this is now sort of the announcement. We are working together, forces combined at the current state. You mentioned some tremendous numbers on the amount of products or raw materials you already have in there. So there is quite some data, and I'm pretty sure it will be filled with more data on and on and on as we speak, literally. What to expect? What to expect from that partnership? What to expect also on the customer side? Where does it drive value for me in the next couple of months and years to come?
So maybe I start with the engagement models, and then Arne, you can explain a bit. So if you want to engage with us, there's two ways. You can either go for the data first,
right,
and try to get your hands on that, and we'll talk about that. How can we make it accessible? How can we fill the gaps? Because 1,000 chemicals is already covering a lot, but you might have 10, 20, 30 that are not yet there. We find a solution how to model them specifically for you. So this is engagement number one, where you say, okay, I'm interested in the data for now. Engagement model number two is you're interested in the platform, in the automation. Then we come and we run a series of workshops with you to understand where are you, what's your data quality, availability, accessibility of data. And then we scope with you what's the best way to start. And again, you make use of the carbon mines database to accelerate the journey for especially those raw materials that are not yet provided by your suppliers. So maybe Arne, you can add something to that.
Yeah, please, Arne, go on. And we already I'm happy, got the first question in. It's quite long, so we can use the time to read it. But Arne, please go ahead.
Yeah. Maybe some additional steps that we can support with. So if you look into a list of chemicals that you buy, sometimes it's not that easy to match it with the right processes, the right supply chain. So if you have a specific polymer, the composition can be slightly different, and this is also something that we're getting super efficient with, to match this, to understand what is the real product in order to be able to match it with the representative data. So those are all steps to in the end make the carbon footprinting fast and relatively easy. Of course, that's a bit of work to set the system up, but afterwards you have the live view of the emissions. You easily get the updates every year, and you can be sure that you have a system that is certified, certified data, and proper quality. Yes.
So the data everyone, like as a customer, I provide, it sort of has a stamp. So it's really approved. It's not guessed. It's real. I can contribute to the scope 1, 2, 3 pretty clear and how it is done. And in regards also, I would like to bring up the question from Olivier again, and maybe also add to that question, not just like that you say, how are suppliers, are they offering their PCF data? Are they just joking? But on the other hand, also as a customer, how are they willing to share special compositions of products? Because sometimes it's a top secret. It's like how something is set together and then say, oh yeah, we could calculate it, but you would have to give us your secret. How is that done? Maybe as a second part. Who wants to go for the question from Olivier?
I just say the first thing, which is only in the chemical industry, suppliers are also the customers in many cases. So not so easy. There's a lot of circular economy there, but not in the sense of circular economy, but companies being their customers and suppliers and competitors at the same time. So that keep that in mind. But Arne, please.
Yeah. But it's absolutely correct, sir. And this is a huge barrier to primary data collection. If you had the energy demands, the resource demands of your supplier, you can easily calculate the costs, which is quite a nice thing to have in a price discussion. So this is super confidential data. It's difficult to pass on. So what is typically passed on are the environmental impacts, so the results of the environmental assessment. But even this is something that sometimes goes a little bit slow, and this is exactly where we come in and why you need the secondary databases. So what we have is data for the technologies, for the chemicals in the country, which can then be used, which is representative of the supplier, but not based on the primary data. And this is how the two things connect, I would say.
Okay, that's quite interesting. So it's not that easy. So really data is the value here, and you are working hard to get more data, get it more accurate, but also, like you said, circular economy, we might thought about something else. It's about circling back and forth and who gives what. But right now we are at a start. So could you say that companies are now more willing to share data because they see the importance, not just for their own business, but also for everyone's else? Or are they more secretive right now?
So the willingness will increase in the future. This is what I expect. So I can't predict the future, but it's an expectation. Yeah,
I expect that the effect kicks in that we see with a lot of the sustainability topics, that those companies that are willing to invest to get accurate data will see that their accurate data is better than their estimates and averages, because they are already aware, they're already acting, they're already conscious about it. So once they look closer, once they get it better, then it's a benefit for them. So that's an effect that we see, that those companies that invest do this because they believe they will do better, actually, than what they assume. So the same with those suppliers. The suppliers that think we have a really good product with a very low footprint, they are willing to share that PCF, obviously. And those believe, we have so homework to do, they will keep it for themselves for a little while, try to bring it down significantly, ideally with our help, and then release it with even more confidence.
Well, you also mentioned something that's like now we're getting the possibility of setting some benchmarks. So from the more users we'll have or will use the system, or the more products or product raw materials will be screened, there will be some benchmarks and how much it is better, and that might also attract others so they can really see the value very fast. Are there already some benchmarking values available which we could share by the time now? I know now this collaboration is quite fresh, and I don't know if you want to spoil too much on that and say like, no, if you want to know more, please follow us on that link. But is just like, is it something where you see it's in the tiny area, or something significant where you say, hey, you should have a look?
Maybe first of all, this benchmarking data, this comes from the database that we are in developing, and this is not the primary data of the tool. So if someone puts in primary data in the tool, it's safe, so we won't see it. But we did the calculation based on process simulations, based on information what technology who is using, and this is why this data is good as a benchmark. You have a consistent calculation, which is not primary data. It allows you to understand if the primary data that is coming in is of good quality, if there might be some mistakes in the calculation, some strange methodological assumptions, and so on. And this data is fully available and can be used for benchmarking right now.
Okay.
Razor, to your question, the positive impact, as Arne said earlier, if their factor is 10 and higher between what you had before and what you're using now to calculate, you immediately see how much more accurate you can become.
Yeah, I know. I just wanted to indirectly come to that 10x again, because, well, 10x, that's something. That's not 0.1% or something. It's quite a lot. If you're fine with that, I see now questions are coming in as we talk, and we promise to get those questions also answered during the session. And we still have a couple of minutes left. So thank you for everyone putting in the question. I will shut up. Please, Arne or Stefan, are materials resulting from recycling processes included in the database already?
Yeah, so we can cover them. Some at the moment, there are just quite a lot of different recycling processes. So what is well covered at the moment is everything that is already built, but we're quite hard on a renewables database with all the renewable feedstocks. Yeah, so if there's a process you need, it's worth contacting us, and we can tell you right away if we can deliver it, when we can deliver it, and so on.
So also recycling processes can be modeled, if not already there. So it's what you say, like each and every production step in some way. It's really about like from the beginning to I have it in my hands. That's what you calculate, and even more. Okay, that's awesome. I also need to understand it sometimes because dealing with that numbers and all that.
If you think about it, it's just another feedstock that we're going to use in the future, and if you put it in the beginning of the change, all the results along the production chain will improve through this. So it's super important to get right.
Sure, absolutely important. So I love this topic, and also the participants. So this is why it's now the third show on decarbonization. The second question was already there. We'll just bring it back again. How do we account for use, repair, end-of-life recycling carbon footprints?
Yeah.
Okay, so maybe I can answer for the tool at the moment. What we're focusing on with the tool is the production steps. So at the moment, we look at cradle to gate, so you can tell your customers how much kilogram CO2e per kilogram of product. An automated calculation of the use, repair, end of life is not yet included, but we're looking at that, obviously, as we do full life cycle assessment as well. So talk to our life cycle assessment experts if you're interested in that. That would be my answer to that question. Arne, I don't know if you have anything to add from your perspective.
And our position is to provide the upstream supply chain. So basically, it's called from cradle to gate. So from the beginning to the factory gate of your supplier. The reason why we do this is if two different companies buy the same, have the same input, their use might be super different. Also where they send it to, where their customers are, what the end of life is. So this is something we cannot know and also will not know in the future. And this is something that will happen in the tool later and needs to be customized by the customer.
Perfect. Thank you so much for this. We have another question to come. Maybe we could bring this up, which would be great. And then we are already nearly at the end of the session. So how do you deal with the high uncertainties of lifecycle inventories?
Yeah. Maybe short answer is we're brutally honest. We are super transparent about the data quality that we have in there. And for most processes, we have very, very good data quality, very high level of very specific data, difficult to write, so that we really model the processes in the supply chain. If there's a customer asks us for a certain chemical where we have worse data quality, then we really have this high uncertainty. We don't have high uncertainty for all products, but then we will tell them.
Same for the tool. Same for the tool. So what we try to show in the tool immediately after the first calculation, how good is the quality of the data sources we use? Does that come from a global average that we want to avoid, but does it come from that source? Is that an accurate region-specific CAS ID, so really product ID-specific value that we're using, etc., etc. Those kind of quality indicators will be shown to the people running the calculation.
So it's like absolute transparency, which is a great thing. Like now, looking at the time and nearly coming to an end, Arne, may I ask you, what can we expect from your point of view in the next 3, 6, 9 months, or just like say a year? Is there something you could mention? You see, I think those 3 things will come that will change it.
Yeah. I think in terms of collaboration, we will keep on improving our database. We will integrate it closer and closer with the software platform for the calculations in the end. Stefan and I, we talked so much. We have so many ideas on potential improvements to make it easier and easier. So what we want to achieve by this, we want to lower the barrier for chemical companies to really do portfolio-wide carbon footprinting and assessments. So that more and more companies can do it. And this is my step 3. So I think we will see many more chemical companies doing really environmental assessments of scale and communicate meaningful data on the environmental impact. This is going to happen in the next years.
And
that's perfect. Yes,
another thing,
Stefan.
I'd like to state we're also going to be looking at other impact categories. So today we look a lot at carbon, and there's a high demand in the industry, but we also know that a lot of customers are very eager to look at a water footprint, acidity, land use, ozone depletion, you name it. So we are already in the first steps of making that a bigger solution for more than just carbon as an impact category. So stay tuned.
Yeah, stay tuned. Is it good? Well, there was a last question coming in. Would it be fine for you to take it? Yeah?
Yeah.
Because we said like, okay, we take in also that last one. And how do you deal with different methods used for the LCA data, subsequential cutoff, etc.? Who wants to take this before we come to an end?
I think this goes to me, and this is a complex one. LCA methodologies, it's quite complex. If you read the standard, it's quite long, and there are sometimes certain methodological choices. What we did, we have a full methodology document where we document our choices. And these choices are consistently applied to every single data set that we have. And this is a big point. So we don't mix results from different sources, different methodology. We have a super clear methodology. All these points that are mentioned in the question are documented in there, and you can be sure that it consistently applied with the database.
Same for us. You can download the methodology on the BASF website.
That's absolutely great. So yeah, also putting that, we're going to put the links maybe if available later on in that. If any one of you wants to learn more about how Atos can accelerate your journey to net zero, we're also going to put that link into the chat here directly afterwards so you can access it. So I would say those 30, now 35 minutes went over like a blast. It's always the same. We're planning to go short and then we go over time. But yeah, I think it's such an interesting topic. And I'm so sure, Stefan, that won't be the last session on decarbonization. We see the interest raising, the question raising. So I would like to thank you a lot. Arne, thank you for being with us today. Hope to see you soon again and looking for everything that is coming up together with Carbon Minds. Thank you. Have a great day. Bye-bye, Arne.
Same here. Thank you so much.
Yes.
Bye.
And also thank you, Stefan. It was a pleasure to have you here again. Looking for session number 4. I already took him off the stage because in regards of time. If you want to know anything special about decarbonization, about the product carbon footprint, about how Atos is tackling, but also supporting, please feel free to reach out. In this event, you also see the speakers in the little card, so you can directly contact them or also place your questions in the chat when you review this video. It was, again, a great pleasure to have you all here. Have a great day, stay safe, and see you in the next Atos Manufacturing Fireside Chat. Bye-bye.